July the 17th, 2020. Guys, it's hot here in Mississippi. I know it is in a lot of places. We've been getting well above 100 in the heat index for the last few days. I've seen 116 here on my small weather station. It's 106 now at 2:34 p.m. Central Time here. That's the heat index, 106, saying 91 degrees with 67% humidity. And guys, Earth's weather is controlled by space weather. Every drop of rain, every time you feel the wind blow, every storm, it's all created mostly by the sun, but sometimes you have other events. And what you're looking at is the Discover satellite. They're linked on our website through space weather. But in the gold line in this graph here, this is called the density of the solar wind. In other words, the thicker this is, the more impact it has on our shields, which are very weak because of grand solar minimum. And a lot of times when the solar wind picks up and moves very fast, and that's indicated in the purple line, the green line is the temperature of the solar wind as it's coming towards our planet. But sometimes you see a peak in the solar wind, and this is pretty mild. It's usually between 3 and 350, so you can see it's elevated. And right in this time when we're seeing this disturbance, it's around 429, and these are kilometers per second. So when you start getting around 600, you're talking approaching 1,000,000 miles an hour, especially during the spikes. But right now it's slightly elevated, but this section in the density that you're seeing right here in the orange, let me back now. This is a 3-day chart, so you're looking at Wednesday, Thursday, and Friday today. And this afternoon, right here, we had a sudden drop in the density. Again, usually when that occurs, you have a spike in the solar wind. The faster the wind, the more it scatters out these particles. That is the density, the energized particles, and everything else that's connected with solar wind. But you see a sudden spike in solar wind, and it's just like if you've got a campfire and it's smoking. If there's no wind, it's real thick. But if you get some wind going up in speed, it blows that smoke away a lot quicker, and it dilutes it. In other words, you got a lot more wind than you do particles of smoke by the time the wind hits it and spreads it out. Same way with the solar wind. You'll see pretty much an opposite reaction in the purple line, which is our speed. As it would spike, you would see these dips. But we saw just a small spike, and what may be happening is what's called a helios sheath, and it's a periodic wave that comes from the sun of an energized wave, plasma wave, that's the opposite polarity, because it's like a wave coming off the ocean, guys, the way that this plasma ring and the solar wind comes at our planet. And at that peak, and then you have a sudden drop in that wave, this thing switches polarity. And so you'll see magnetic fields affected also. You'll see auroras increase. And they are showing up on the Comet images of NeoWise, which is some interesting things going on with that. But guys, when you see a drop like this, it's a drop in pressure of the density. And so pressure works on earthquakes and tectonic plates in two ways. As you compress the earth through increased solar winds and pressure on our shields, that pushes down slightly. But when that energy is suddenly released, just like squeezing a balloon, you have crustal plate movement at that time too. And that's exactly what we've seen today, this afternoon. You've got 2 quakes, a 7 and a 6 down below the equator. We'll take a look at those in just a moment. That link that I just showed you with the solar wind and density, that link is on our website at Space Weather. And just come down this left side and you can see all of the stuff. But if you come here and you look at a couple of things, there's 2 more we're going to look at now. You can come in here to Space Weather, go there on the top left, you'll see a link to Discover Satellite, and that's what you're looking at. It's picking up data that's coming from the sun towards the earth. It's an early warning system. But at the very top is earthquakes. Let's go there a moment. And if you look down towards Australia in the southern hemisphere, you've had this 7.0. This is 114 kilometers northwest of Popondeti Papua New Guinea, 79.8 kilometers deep. Also, here, this is in the Andaman Sea. This is the Andaman and Nicobar Islands. You had this 6.1. You see the aftershocks there too. Now, you're seeing some buoy movement also from the stronger quake. Again, this one's further offshore, but it's in the Coral Sea, just off the edge of the Great Barrier Reef, right there in the Coral Basin. And it's just showing a quick movement there in a 15-second timeline. I'll show you that. Not a lot of wave pattern. I did not see a tsunami warning, probably because of the type of the quake, the shift that it was. It wasn't a large drop in the ocean floor under a subduction zone, but this wave that crossed the Earth after it crossed the Discover satellite, those things affect our planet just like the blast from a CME or coronal mass ejection, anything like that, a solar flare. Now, if you click on that buoy to give you this information, it's water column height, and in the blue, these segments are 15 minutes. And in the green, you've got 1 minute changes, and then in the red, right, when the quake struck, here are 15-second increments. Again, you're only going about not even a full meter in change. You've got 59.4 or 55.94 in meters in depth. Then it goes to 45.95 and a half. So a meter and a half was the change. But that would be enough to feel it if you're on the beach or your small boats are tied up or something like that. But again, no tsunami warning. But when we see this happen, that's what telling you the planet got its bell rung. And there's other indicators that may be what happened. This magnetic sheath, this plasma wave of opposite polarity that struck the Earth, may be what we're seeing with some of the photographs that are coming in on Comet NeoWise. Let's check one out. Now, going back to our website, the next link that I want to show you is space weather, and it's down on the left right here under the ACE satellite link, which also gives you solar wind information. Let me say this quickly. Guys, it's not that popular to do a lot of political videos right now, and so if there was a lack of information, it would be more important to do it. But let me tell you this, and listen closely and listen wisely. The information is out there on a daily basis. You've got Breitbart, you've got Gateway Pundit, and Zero Hedge. They will pretty much wrap it up without the same mainstream hype that we're now seeing from all of the networks, okay? So you can go there and get a complete look at what's going on. Zero Hedge, right now it's talking about the banks are in trouble. We're seeing more and more people now not taking cash, or you got to have exact change. They're getting ready for a change, guys, in the entire New World Order system. And what we're seeing is a battle to control that, whether it's left or right. Each one has a different vision of their vision of the New World Order. And that's what the battle is about, who is going to run it. It's coming, or they wouldn't still be talking about the V word. You understand? And that's very prevalent. Look on those 3 websites I'm telling you about. You can get a daily dose, enough to make you throw up, I promise you. But it will keep you in the heads up better than any YouTube channel could do it. You could take an hour to read all 3, and you can't put that much information in a video. But just pay attention to where the food problems are going to come, and watch the banks, guys, because remember, the last time they were bailed out, this time the laws have changed. They'll be bailed in with what? You know what. So prepare for that. And just very quickly, we still, if you go to My Patriot Supply website, this is $297, a 4-week supply. Comes in these 2 buckets. It's $100 off if you come here, and that's a great deal, guys. But come over to Space Weather, right there under the ACE satellite. Click there and come to Space Weather. Right in the center, you'll see this article. It's today on the 17th. These are called synchronic bands of Comet NeoWise. What you're seeing in the white, and we've talked about it before, that is more or less the debris trail that's blown back in the direction that the comet was coming from. The thin blue line is called an ion tail, and if you trace that straight, it would go to the sun, because you've got, again, the movement of the comet leaving the debris trail, but then you've got that solar wind stream. And they've noticed that there's some interruptions in it. It has everything to do with this density we were looking at, that sudden drop in the earthquakes. But it's saying Comet NeoWise is doing something usually reserved for great comets. It has sprouted synchronic bands, also known as stria. These bands divide the comet's dust tail into linear regions of greater and lesser density. Guys, this is shot by Chris Cook from Cape Cod, Massachusetts. He captured this on the evening of July the 15th, 2 days ago. And they've got a closer up, but these bands, you can see them here, and you see where it's like a shadow going through them. And they've seen it for years, and Comet McNaught was one of the classics. You could see that band all the way across the sky at night. Look up Comet McNaught, and you'll see the most amazing comet image. They were like this, but again, covering half the sky. And what happens is when they go through what's called a helios shift, this wave that comes from the sun in these wave cycles, it will disrupt the ion tail. It will scatter this the way you're seeing these bands here. And what is happening, and they're now getting the information, they see it when a comet's getting very bright. And sometimes they will get so bright that they will separate. The nucleus will become multiple nuclei. And then it will go through a sudden dimming. And so each one of these streams, or possibly what they're thinking now, is different chunks that are hidden behind the brightness inside this core. Some are streaming behind it. We saw it with Comet Atlas. That's why it dimmed after rapidly brightening. But again, these synchronic bands are from different objects inside the nucleus, or inside that central area. And the waving that you see from the ion tail here, and these gaps, are from the helios sheath, or this plasma wave that we went through. Now, let me read some of this. It says, Comet NeoWise is now in its full glory for Northern Hemisphere observers. That's us. This image is a stack of 30 25-second exposures at ISO 1600. It clearly shows the formation of these synchronic bands within the dust tail. Synchronic bands have been seen in comet tails before, and this is going back to Comet McNaught. It says, apparently, the process starts when a chunk of comet detaches itself from the nucleus. Boulder-sized chunk fragments into smaller and smaller pieces, a cascading process shaped into these dusty striations by solar radiation pressure. And that radiation pressure changes if you go through a magnetic sheath. And they point it out right here under this image. It says, a few years ago, then PhD student Ollie Price of University College's London Mullard Space Science Lab was looking at old pictures of McNaught and noticed some weird goings on. The bands were occasionally being bent and disrupted by some invisible force. So he set out to investigate what might have happened to create these weird effects. Price and colleagues ultimately found the answer. The disruptions occurred when Comet McNaught crossed the heliospheric current sheet, or an HCS, a vast wavy structure in interplanetary space separating regions of opposite magnetic polarity. It appears the dust may be electrically charged and gets rearranged as it crosses this boundary, going from negative to positive. Guys, I think we're already seeing some of those effects in NeoWise, and this article says, could the same thing happen to NeoWise? It's possible. Photographers monitoring NeoWise are encouraged to keep a sharp eye on this stria. Changes may be in the offing. Now listen, the sky maps for tonight are here, last night, and tonight. Let's look at tonight. Now that will take you here, looking northwest after sunset tonight on July the 17th. You got the Big Dipper and Little Dipper. The Little Dipper has the North Star Polaris right there. Big Dipper under the handle. Straight south of the bucket itself, or the Dipper, is Comet NeoWise tonight. So if you scroll this down, this gray area is the horizon. The sun has already set. See that? The Earth, if you're looking into the sunset, guys, and so you're sitting in your lawn chair and watching the sunset, the sun is not setting. The Earth is spinning you backwards. very fast. Okay, that's what you're actually seeing. So the sun is here, it's already set, and again, like I said, a little north of where the sun is setting, you're going to see NeoWise. Now again, all through parts of the night, early morning, it's getting visible. But I just wanted to point this out, guys. It's a very interesting. This comet won't be back for over 6,000 years. We will never see it in our lifetime again. So check it out, and you don't get these that are what they're calling very close to a great comet very often at all. But we're watching it, guys. You watch it. It's a heads up. Be safe.